Hey guys, time to do chapter 14 sticky notes. This is a pretty long chapter, a pretty beefy chapter, so we'll see if I can get through this as quickly as possible on water pollution. All right, so to start off talking about the different sources of pollution, and they're known as point or non-point. So you definitely need to know the definition of point sources. These are sources of pollution that can be pointed out, that can come from one specific place, so know some examples, and then non-point. Know the definition of non-point sources and then examples of that. So human wastewater is a common pollutant, and what we see is that many people throughout the world use the same water source for drinking, bathing, washing, and disposing of their sewage, which causes huge problems, which causes high nutrients in the waterway and the spread of disease. So we'll be talking about kind of human stuff, human wastewater, human waste stuff first. So one aspect of this is oxygen demand. So the more microbes there are that are feeding off of the growth in the waterway, the more oxygen they demand, and that's called BOD, or biochemical or biological oxygen demand. So this can lead to areas that are called dead zones or hypoxic, and that means that they're low in dissolved oxygen. And cultural eutrophication also leads to this, which cultural eutrophication would be anthropogenic or human caused. And the main causes of cultural eutrophication are agricultural runoff and wastewater release. So you can see here just an example of a dead zone in the Gulf of Mexico. So then let's talk about eutrophication. And it's important that you understand the steps of eutrophication. So to start off with it, eutrophication begins because of an increase in nutrients, and then that causes an algal bloom, and then the algal bloom dies. So you've got a lot of algae growing, and then it all dies, and then the microbes start to digest the algae and use up the oxygen in the water. And so the more algae there are, the more microbes there are. The more microbes there are, the more oxygen is used. So that causes a decrease in dissolved oxygen levels, and then result in large die-offs of fish and other aquatic organisms. It's important to know the difference between eutrophic and oligotrophic, and we talked about this actually in chapter 9, but I just wanted to make sure that you knew, that you remembered where it came from. Okay, so then we talk about disease-causing organisms, and fecal coliform bacteria is one of the best indicator species of if there's waste and if there might be other pathogens in the waterway. And E. coli is the most common species that is used to test, because it's found naturally in human intestines. Okay, and so then poverty-stricken low-income areas usually lack sanitary waste disposal, which leads to spread of infectious diseases. And so the two that College Board definitely wants you to know about are cholera and dysentery. And cholera is because of the vector is a bacteria that's found in infected water. It causes like massive diarrhea, like bad. And then dysentery, pretty much the same thing, caused by untreated sewage in rivers. I don't know if you guys ever played the Oregon Trail, but a lot of people died of dysentery back in those days. Diarrhea. Okay, so then talking about ways to treat, you don't need to worry about this. It talks about septic systems here. We don't need to worry about that. So I want you to focus on sewage treatment plants, and there are kind of different levels of the treatment, so you definitely need to know this. So you have the primary treatment, which is the first part, which uses screens to screen out any big trash, and then the settling, which all of the kind of solids and things will settle out, and then they get rid of that sludge. Then the secondary treatment is a biological treatment, and so this is where they add bacteria that are used to break down and decompose all of the organic matter that's found in the wastewater, and it's aerated to add oxygen so that the microbes can be nice and happy with all sorts of oxygen in there. I'm just trying to. Okay. Then the tertiary treatment is a chemical treatment where they remove the excess nutrients, specifically nitrogen and phosphorus. And then prior to discharge, they're going to disinfect the water to kill the bacteria that they added in during the secondary set, using things like chlorine ozone or UV light. Now, issues come about with sewage treatment plants when there's heavy rain and it causes the treatment plants to overflow, and so sometimes raw sewage can overflow into waterways and rivers, which is obviously a bad thing. All right, figure 14.6 is a good example of a sewage treatment plant. So you definitely need to know like the steps of sewage treatment, know what's happening during primary, secondary, tertiary, and prior to discharge. Okay, so here then we're going to talk about other types of pollutants besides wastewater, and so we'll talk about heavy metals. And so kind of the big three, and sorry that my dog got into this. The big three are lead, arsenic, and mercury. And lead can be found in old pipes, lining old like water pipes, and lead damages nervous system. So the best example I always think of is Flint, Michigan, and everything that was happening there. And of course, children are the most susceptible to damage from lead. Arsenic actually occurs naturally in Earth's crust and rocks, but it also comes from human mining when humans mine the rocks, and arsenic is a carcinogen. So that can be found in waterways. And then mercury can be found naturally, but most of it comes from burning of fossil fuels. Just trying to make sure you can read that. That says human mining there. And so the problem with mercury by itself is not really a big deal, but once bacteria in the water convert the inorganic mercury to methylmercury, then it becomes highly toxic. Then it's a problem. And that will lead into what we are going to talk about, which is called bioaccumulation and biomagnification. And this is covered on page 478, so it's in a different chapter, but I do want you to go and look at it because you need to understand bioaccumulation is the idea that toxins will accumulate in the fatty tissues of organisms, and then biomagnification is the idea that as you go up the food chain, the trophic food levels, that it magnifies in intensity. So by the time you get to the top of the trophic levels, like the top carnivores are the ones who are affected the most. So effects of bioaccumulation, biomagnification, eggshell thinning, developmental deformities in top carnivores. Human effects from biomagnification, bioaccumulation are issues with reproductive, nervous, and circulatory systems. So the three good examples of substances that bioaccumulate and biomagnify: DDT, mercury, and PCBs. We'll talk about the DDT and PCBs in a little bit. Okay, so then it talks about acid deposition. Acid deposition is pretty much just acid rain, and it makes sense that acid rain reduces the pH of water bodies. It also comes from underground mines, which release acid into groundwater. So both of these ways can lower pH of waterways, which we know can be dangerous and stressful. So different solutions are coal scrubbers and smokestacks to help clean the air that's coming out from the industries, and also possible limestone treatments. Limestone is a base, and so treating the water to help raise the pH back up. Okay, then it's talking about some other water pollutants like synthetic organic compounds, and the College Board talks about them specifically as persistent organic pollutants, or POPs. These are synthetic carbon-based pesticides most of the time, or compounds, and they don't break down easily in the environment. They are soluble in fat, and so they accumulate in fatty tissues. This is where kind of the bioaccumulation comes in fact, and then because it stays in as things get eaten, it magnifies up the food chain. And POPs can also travel long distances by wind or water, so they're like super persistent. I mean, hence the name persistent, and they just stay around for a long time. So a couple different examples of POPs that are covered that you need to know are DDT, so it's talked about here, and then PCBs, which are actually talked about over here. So DDT is an insecticide that was used like massively in the 70s to kill mosquitoes, but then is not used so much in developed countries, but still actually used in developing countries, and it has a major effect on birds, on their eggshells, thinning of eggshells. So there's a book, very popular book called Silent Spring by Rachel Carson that talks about this. And all right, so then we have PCBs. These are used in manufacturing of plastics and electrical transformers, and they're no longer made actually, but they still persist, like they're still around. And these guys are carcinogens, and PCBs can actually like soak in like other toxins too, which can make them very dangerous. So there's some different things you don't really need to know about, like the PBDEs and some of these industrial. I mean, just focus on the ones that I'm telling you about. Now, this one talks about pharmaceuticals and hormones. Specifically, you need to know them as endocrine disruptors. And again, this is also covered in another chapter. So I linked the page here for you, page 473. These are chemicals that interfere with endocrine system. I mean, this is your hormones, and can lead to birth defects, developmental disorders, gender imbalances in fish and other species. So just all of these are different water pollution examples. All right, so then specifically talking about oil spills, organisms die from the hydrocarbons in oil. So either they ingest them or they get on them and kind of suffocate them. Surface oil will coat feathers and fur, preventing, again, like suffocating or preventing birds from being able to fly. Some oil also sinks, which will kill bottom-dwelling organisms that feed on it or that it covers. Now, the worst oil spill in history was in 2010, the BP Deepwater Horizon spill, and they saw lots of effects of this, and there's still oil around, but economically, oil spills have an effect on fishing and tourism industries when oil gets on the beach or when it kills fish. So it's important to note that not all of the oil in the ocean is from oil spills. More than half, about half of the oil in oceans comes from natural seeps. So it seeps naturally from the ground, from the ocean floor into the ocean. So just something to think about. But then there is a lot that comes from, then it comes from transportation of oil, like by boat, extraction, things like that. So what are some of the remediation methods that can be used for oil spills? There's physical, chemical, and biological ways to remediate. Physical would be things using like booms, which kind of corral all the oil in one place, and then they can use this giant vacuums to vacuum up the oil. There's also absorbent material like hay and like cotton, stuff that just kind of absorbs it, and then they can throw that absorbent material away. There's chemicals. You can disperse chemicals into the water that disperse the oil and that cause the oil to break up, but these chemicals can actually be toxic too, so there are some issues there. There's also some biological methods. They have this genetically engineered bacteria that actually likes to eat oil, so that's pretty cool. Okay, so then the rest of the water pollutants, it talks about the non-chemical ones. Solid waste pollution. We've got sediment pollution. We have thermal and noise. So what you need to do for these four things is to know the causes. What causes solid waste? I mean, that's going to be trash, garbage. Sediment, that's usually from construction. And then like thermal, a lot of times that's going to be from like extremely hot water coming out, usually from like a nuclear power plant or something like that. And then noise pollution would be ships and the sounds and different things that are made. So know the causes and the effects of each. So what is the problem with sediment pollution and noise pollution and thermal pollution? Okay, so those are covered in the chapter, so you can do that. All right, and then kind of finally it talks about the legislation. So you do need to know the Clean Water Act and the Safe Drinking Water Act. These are two that must be known. And what you'll see with economic development is that the higher the economic development of a country, the cleaner the water tends to be. So you need a good understanding of what these two acts are and what their purpose is. And that is it.